Try again. All right, gravitational potential energy and kinetic energy. And kinetic energy. Can you see it all? So gravitational potential energy and kinetic energy. First of all, last week we said that if you take an object up to a high height, like to the top of a wall, you could take that object and you could drop it off the edge of that wall. And by the time it falls down to the ground, what can you tell me about the speed when it gets down to here? Yeah, it'll be faster. I mean, even if this starts out with a little bit of speed up here, it's going to be more speed down here. But if it starts from rest, definitely it's going to be going downwards. At the instant of impact, it's going to be going downwards, okay? Forget about what happens after that. At the instant of impact, it's going to be going downwards. And so people could talk about the gravitational potential energy up at this point. And what was the type of energy it has down at the bottom? Do you remember? What type of energy does it have when it's moving? Kinetic, yeah. So people talk about Eg, G for gravitational potential energy, and Ek, K for kinetic energy. And if I was talking about taking the same mass and dropping it off of a lower wall, like here. I drop it off of that wall and it hits the ground. What can you tell me about the speed when it hits the ground after falling off of a lower wall? Greater or smaller than it was falling off of a high wall? Yeah?
Smaller.
Smaller, sure. So you might say that it has a smaller kinetic energy. What might you say about the gravitational potential energy that it started out with? Greater or smaller than the original scenario? Well, it's first scenario, it started up here. Second scenario, it started down here. Which one has more gravitational potential energy, do you figure? The one that's higher up has more Eg. You're higher up. You have more potential to fall fast by the time you get to the ground. So you have greater potential energy. Now, if I wanted to talk about these guys like in terms of scenario 1 and scenario 2, how about scenario A and scenario B? So this is gravitational potential energy at the top for scenario A. This is kinetic energy at the bottom for scenario A. And this is gravitational potential energy at the top for scenario B and kinetic energy at the bottom for scenario B. Tell me, using greater than or less than symbols, we can talk about EGA and EGB. Which one's greater? EGA or EGB? A. No problem. Which one's greater? EKA or EKB? What's that? EKA, yeah. Actually, some people in my first period class even talked about, or my second period class rather, talked about what you could talk about in terms of equalities. If this guy here has all of its energy wrapped up in gravitational potential, does it have any gravitational potential down here? Does it have any height down here? Probably no gravitational potential. Where did all the energy go to? Yeah, it became kinetic. So you might even say Eg at the beginning ends up being equal to Ek at the end. Well, you might even go one further than that. You might say Eg at the start plus Ek at the start equals Ek at the end plus Eg at the end. Well, not gen, but Eg at the end. And that's probably true. I mean, this is kind of like saying the total energy that I start out with is going to be equal to the total energy that I end with. Now, in this really simple scenario, what's EK at the start equal to? What's the kinetic energy up here at the beginning? 0. 0. What's EG at the end equal to? 0. So all we're saying is that in this particular case, where all of the gravitational potential energy gets turned into kinetic energy, in this particular case, EG at the start is equal to EK at the end. Now, most people don't use the subscript start and end. What they would really more typically do is use EG, instead of saying start, they'll say at time 1 is equal to EK at time 2. Or people also use EG initial and EK final and that sort of thing. And some textbooks will have lowercase I and lowercase f instead of the 1s and 2s, but more commonly you see the 1s and 2s. It's a little bit more language universal. Okay, I and f is really specific to English. And speaking about this whole thing of being particular to English and having some sort of a universal standard for communicating these ideas, what you'll find is that a lot of people will use EG, and we're going to use EG for gravitational potential energy. And a lot of people use EK, and we're going to use EK for kinetic energy. But not everybody does. You're going to see, and some of you have brothers or sisters, you have parents that are engineers. Maybe you'll be looking at things online to try and figure stuff out, like try to teach yourself like a little mini lesson or something like that. And when you do that, sometimes you'll see people using the notation capital U for gravitational potential energy. Sometimes you'll see people using the notation PE for potential energy. And sometimes you'll even see GPE for gravitational potential energy. For EK, the same people that would use capital U would probably use capital K. Now these two are the most common ones that I see. But even those ones like U, what makes U sound like gravitational potential energy, it's not totally expressive to us. So we're going to go with EG, because that's what our textbook uses, and the subscript is fairly expressive, okay? But just so that you know, capital letter U is equivalent to EG, and it's equivalent to capital P, capital E, capital GPE. They're all equivalent. I don't like these guys here particularly, just for myself, because I don't like having multiple letters represent one variable. But it doesn't make them wrong. I would just slash them out because I'm not a lover of those ones, okay? You might be a lover of them. Or maybe somebody that's helping you with your homework might be a lover of them. So I wanted to make sure that you knew that they were there. All right, I want to try doing a calculation. Can I take this sheet away?